Example 8 asks us to find the integral of sine squared of x dx in each of the following two ways. Part A wants us to use the identity sine squared x equals 1/2 times 1 minus cosine of 2x. And if you remember at the beginning of part 1 of this video, if you look at the table of trigonometric identities, this is called the power lowering identity or formula. And I often abbreviate identity with ID. So let's go ahead and do that. In the previous examples, a lot of the trig functions that we were integrating dealt with odd powers, and so now we're going to take a look at even powers. I'm going to go ahead and factor out 1/2 outside of my integral. Now what I want to do is I want to break this apart into two different integrals. Using integral properties. Now on this second integral, I'm going to go ahead and use u substitution. I'm going to set u equal to 2x. du is going to equal 2 times dx, and then we get 1/2 du is equal to dx. And this first integral, that is going to give us 1/2 x, and then I'm going to have minus 1/2 times the integral of cosine of u, and then dx is getting replaced with 1/2 du. So now this is equal to 1/2 x minus 1/4. I'm going to pull out the 1/2 and multiply 1/2 times 1/2. That gives me 1/4. And then we have sine of u plus our constant of integration. And then we just want to go ahead and replace u. And there's our final answer. Part B wants us to solve the same integral, but now with integration by parts, and it tells us specifically to make u equal to sine of x and dv equal to sine of x dx. So I'm going to rewrite sine squared x as this, and off to the side here, I'll make u equal to sine of x, and then du is going to equal cosine of x dx. dv we're setting equal to sine of x dx. And then v is going to equal negative cosine of x. Okay, so now we have this is equal to negative sine of x times cosine of x minus the integral of v du. So I'm going to go ahead and factor out the negative sign, and then if we multiply, we get cosine squared x dx. Now what I'm going to do is I'm going to go ahead and rewrite cosine squared using the Pythagorean identity. So I know that this is the same thing as 1 minus sine squared x. And from here, what I can do is I can break this up into two separate integrals. Okay, so I've gone ahead and just rewritten what we are, or where we're at this point, and I have the original left-hand side. And if you watched the videos on integration by parts, you might have remembered the portion where we talked about recurring integrals. And so at this stage, you'll notice that we have this integral here, and we have this integral here, and those are the same integrals. And so the trick that we can do is I'm going to add this to both sides. And if I do that, then on the left-hand side, I get 2 times the integral of sine squared x dx is equal to negative sine of x times cosine of x. Then the integral of 1 dx, that's going to give us x. And then at this stage, what I can do is I can divide both sides by 2. And don't forget our constant of integration. So that is our final answer here. And you might be asking yourself, hey, that doesn't look like the answer that we got in part A, so let's address that. So part C says, show that your answers to parts A and B above are the same by giving a suitable trig identity. So I'm going to go ahead and work with part A. I have 1/2 x minus 1/4, and you might remember from trigonometry, I can rewrite sine of 2x using the double angle identity. And if I rewrite that, that is the same thing as 2 times sine of x times cosine of x. And so what happens is we get 1/2 x minus, and then this 2 and this 4, that will become 1/2 sine of x times cosine of x plus c. And both of those things have the same denominator, so this I can rewrite as x minus sine of x times cosine of x over 2 plus c, which is the same as that thing. So I'll just put a check mark to show that we verified that our answers from part A and part B are the same answer. Example 9 asks us to evaluate the integral of sine squared x times cosine squared x dx. So in this case, we have both even powers on sine and cosine. So what we're going to end up using is the power lowering identities for both sine squared and cosine squared. So if you don't remember the power lowering identities for sine, we have 1/2 times 1 minus cosine of 2x. And then for cosine, we have 1/2 times 1 plus cosine of 2x, and then dx. So now what I can do is, I have 1/2 times 1/2, that gives me 1/4. I'm going to factor that outside of my integral. And then I have 1 minus cosine of 2x times 1 plus cosine of 2x. I'm going to go ahead and multiply those together. You might be able to recognize that that is a difference of squares, so I have 1 minus cosine squared 2x dx, like that. I'm now going to split this up into 2 different integrals, so I have 1/4 times the integral of 1 dx minus 1/4 times the integral of cosine squared 2x dx. And on this integral here, I'm going to use the power lowering identity once again, but be careful, the inside of it is 2x, so we have to be mindful of that. I'm going to go ahead and evaluate this first integral. We get 1/4 x, and then I have minus 1/4 times the integral of 1/2 times 1 plus, and then it would be cosine of 2 times the angle that we have on the inside, so 2 times 2x would be 4x. So now I have 1/4 x, and then I can factor out the 1/2, and that gives me minus 1/8 x, or just 1/8, and then that's times the integral of 1 plus cosine of 4x dx. And then that integral now, I can once again split that up into 2 different integrals. So I have 1/4 x minus 1/8 times the integral of 1 dx. minus 1/8 times the integral of cosine of 4x dx. For this last integral, we can use u substitution on that. So I'm going to set u equal to 4x. That's going to tell me that du is equal to 4 times dx. And then if I divide both sides by 4, we get the following. So now I have 1/4 x minus 1/8 x, and then minus 1 over, I'm going to multiply the 8 and the 4 in the denominator, so that's going to be 32, and then we have the integral of cosine of u times du. If I find a common denominator for those, that would give me, and if I combine that, then that should give me 1/4 x. So here this is equal to 1/4 x minus 1 over 32, and then the antiderivative of cosine of u is sine of u, and then if I plug in my u value to be 4x, and then add our constant of integration, this is our final answer. Example 10 wants us to evaluate the integral of sine cubed x dx again, but this time using integration by parts, where u equals sine squared x and dv equals sine of x dx. After this, we'll probably need to do a substitution. So I'm going to rewrite sine cubed as sine squared x times sine of x dx, which coincidentally is the same way we started the last time we did this, but then from here we use the Pythagorean identity, but now it asks us to use integration by parts. So we're starting off by setting u equal to sine squared x, and then if I take the derivative, we get du equals, I'm going to bring the power down, so I have 2 times sine of x, and then from there I need to use chain rule and multiply by the derivative of sine of x, and then dx. And then dv, we have, it tells us to make that equal to sine of x dx. And if we integrate, we get v equals negative cosine of x. Okay, so ultraviolet, we have negative sine squared x times cosine of x minus the integral of v du. So I have negative cosine of x times 2 sine of x times cosine of x dx. I'm going to go ahead and factor out this negative sign and make that a plus. And then I'm going to go ahead and simplify my integrand there. I will factor out the 2, and then we have cosine squared x times sine of x dx. And this is the stage where it says we'll probably need to do a substitution. So I'm going to come off to the side here at this stage, and I'm going to say let w, since we already used u, let's use a different variable. So w, I'm going to let w equal cosine of x, and then dw would equal negative sine of x dx. So now we have negative sine squared x times cosine of x plus 2 times the integral of u squared. And then coming back down here, if I multiply both sides by negative 1. So note that sine of x dx we can replace with negative dw. This should have been a w, not a u. So w squared times negative dw. And I'm going to go ahead and factor out my negative sign. If I do that, that's going to become a negative, and then we have dw here. Okay, So now we can integrate that using power rule. So I have negative sine squared x times cosine of x minus 2 times w cubed over 3 plus c. And then let's go ahead and plug w back in. And here we have our final answer. Example 11 says, for funsies, can you show that your answers from example 2 and example 10 are the same? So I've gone ahead and I've written the answers from example 2 and example 10, which both had us find the integral of sine cubed of x dx, but in different ways. And I'm going to start off with example 10, and I'm just going to drop the c. So I want to show that that is equal to this here. So let's start off with example 10. We have negative sine squared x times cosine of x minus 2/3 cosine cubed x. And this thing, sine squared x, I can rewrite using the Pythagorean identities. So if I did that, then that would give me 1 minus cosine squared x. And then what I can do is I can distribute the negative sign and the cosine into both of these. So if I distribute negative cosine in, we get negative cosine of x plus cosine cubed x minus 2/3 cosine cubed x. And notice that because these are both cubed, these are like terms, and 1 minus 2/3 is 1/3. So this is equal to negative cosine of x plus 1/3 cosine cubed x, which is equal to example 2's answer. So to illustrate that I've proven that, there we go. And that concludes this example.